Good afternoon, everybody, and welcome to all the panelists. Looking forward to this panel talking about innovation and technical challenges in plastics recycling. And maybe I'll start by introducing some of the panelists you haven't met. So starting with Dr. Jeff Brighty, is Head of Sustainability and R&D at the advanced recycler Mura Technology, and has joined the company since 2019. He had a 26-year career in science, policy, and regulation with the Environment Agency in the UK. And before joining Mura from 2014, he was technical director at the UK's first plastic pollution charity, Plastic Oceans, and was science advisor to the NGO's 2016 multi-award-winning film, A Plastic Ocean. Then I moved to Professor Steven de Meester, is associate professor here at the Ghent University, and he leads the laboratory for circular process engineering. His research focus is on better chemical engineering and the circular economy, with focus on pre-treatment and downstream processing. Since 2022, he's also active as part-time professor at Maastricht University, as chair of circular plastics. And then moving to Dr. Engineer Aziz Saoud. He's head of R&D at Prime Cleantech and comes from an interdisciplinary background of mechanical and chemical engineering. He's a graduate mechanical engineering with a master's in energy, did a PhD in India, and then joined the Laboratory for Chemical Technology at the Ghent University as postdoc, where he worked on plastics recycling. Then he later joined also Université Catholique Louvain as a postdoc researcher to work on modeling and optimization of green hydrogen and ammonia production. And myself, as introduced, I'm working for CEFIC as innovation director, focusing on circularity, and obviously the topic of chemical recycling, plastics recycling is part of that. So very much look forward to the discussion, because obviously innovation is a key element to make that transition to a circular economy. It's clear recycling is not the only part of transitioning to a circular economy, but it's obviously a part of it. And obviously mechanical recycling plays its role, chemical recycling, physical recycling, they all have a role to play in the circular economy. But I would like to start with actually asking each of the panelists to give their perspective on some of the progress, the significant progress we've made over the last years in the field of innovation, technical progress, to make recycling technologies actually be able to play a role in the circular economy. And maybe I'll start with Kevin, if you can maybe start, and I would give each of the panelists about 2 minutes because we only have half an hour. So let's start with the progress we have been making in the field.
Yeah, so about 10 years ago, I was starting in this field, and what you realize then is that I will call it that most of the companies were like small farming companies. They produced things at very small scale, created some oil, and then they went to all kind of large-scale chemical companies and they tried to sell that oil and to convince them to take that off. They said, this is the perfect oil, you can do everything with it. And then the big chemical company said, well, that's actually not true. And then, okay, then it became a bit quiet. It was really a lack of understanding of the companies developing technology and the larger players who should be take off for, and so on. And I think that that bridge has been made. So there's understanding what are now the difficulties. They speak at least now a common language. And that's already enormous progress. I think what also people realize is that chemical recycling needs to happen a lot. And there's no discussion about that anymore. That was also sometimes still a bit doubtful 10 years ago. For me, the main thing is the And I think that big and large companies realize that they have to work on things like impurities, scalability, availability of feedstock. These are the key elements to make this thing work. And I think that big steps have been made there also by doing proper LCA analysis. I think that also LCA and TAA analysis have showed us that some routes are better than others. They're maybe not optimal yet. There's still improvement possible. Technology is more or less there. And I think now we are at a place that we need proper legislation to enforce it, to really say, okay, this needs to happen. And for me, that's basically the legacy I want to give to my children, is that basically we step away from waste as being waste, not combust. For me, combustion is not done. That we basically do something with that waste, definitely as Europe, because we don't have a lot of resources.
Very clear, thank you. Yeah, Aziz, your perspective coming from crime, now that you've seen progress over the last years.
I think I'd like to maybe travel in time and take all of you. Plastic recycling is not new. It wasn't born yesterday. It started in the 70s, and it was driven by oil prices back then. In the 80s and 90s, there was like research, development, scaling up, but in the 90s, slowed down. There were lots of reasons back then in the 90s, because like for Greenpoint, there was actually scaling up. But when it comes to the purity of the feedstocks and purity, the cost, when it comes to the market and the economy, it wasn't really visible back then. So it slowed down, and in the past, maybe 1 decade, I can say it's gaining more and more importance. And in our like brief discussion, I thought it's just like Renaissance age for plastic recycling. So from my point of view, it's not new. It's getting accelerated, and the work is being done right now. It's impressive, and the collaboration between academia, industry, and scaling up. I think it's the golden age right now for the plastic recycling. Thank you.
Yeah, thank you. Stephen?
Thank you. So what to add to that? In my opinion, you can make plastics from oil, or you can make it from waste. And in my opinion, making plastic from waste is more complicated than making plastic from oil. And I think the big merit now is that we understand that everyone starts understanding that this is the case, that waste plastics, first of all, it's a solid. It's different than oil, which is liquid. First, and furthermore, all kinds of chemistry is inside. And it involves people, because we have the products and we have to collect it. It involves more than processing crude oil. And you see now, because there were previously some trials done in the 90s also on gasification, and then usually they failed. But you have the impression that, okay, these were sometimes a bit more loose attempts, and now you feel that more and more people are going all in, and you feel the community becoming bigger. You feel that the steps that are taken are becoming bigger, that they are more fundamental, because you understand the problem. You see chemical companies asking, how do I characterize solids, which is a very decent question, which was a question you wouldn't have asked 15 years ago, or maybe even 5 years ago, at least 10 years ago. So you see these communities working and really going all in. And I feel that from a technology perspective, now really the steps that are taken are the steps that are needed. And as we also have to realize that miracles don't exist, and that crude oil to plastic was also a process of R&D. My times, of course, it was a process of years and years of R&D to come to the current steam cracking process and so on, and that we have to somehow go through the transition slowly but surely, with falling and standing up again, and this is what is happening now. But now it's at least happening in a way that I have the feeling that we are making the steps needed. Of course, there is the technology perspective, where I'm optimistic that now we are making the steps. But then, okay, there is the situation of world markets, there is the situation of collection, and then there is the situation now of competitiveness of industries, which further complicates, because as mentioned, making something from waste in many cases is more complicated than making something from oil. And this together with the technical complexity, which is more complex, I think that there we have to be careful how to steer the economy, that recycling, and this is also very relevant for chemical recycling, is competitive, because it was originally only that, okay, mechanical recyclers are going bankrupt. It might also well be that chemical recyclers are going bankrupt. So this is together with the technology, and this is very sensitive debate, but we have to take care of how to make these things, both circular plastics, competitive. Because also it's different compared to metals, which have more value from itself, which are easier to separate from each other, which are processed at 1,000 degrees, which is something different in a way. So but in a way, I'm positive at least about the technological progress which is being made now.
Yeah, and competitiveness in Europe is obviously a key theme that the report of Draghi that was presented yesterday, and also innovation and technical progress in Europe is going to be key. So that's why I was really happy I could facilitate this panel today and hear these perspectives. Collaboration, as you say, is obviously key and great to have a lot of representatives here today from academics, but also industry. And good to have that discussion. Jeff.
Okay, so to validate Stephen's point about being old, my first work analysis in 2005, and it was to do with waste plastic containers on farms full of pesticides that could not be recycled. They were suddenly going it was going into diesel. So this was not going to be circular. But of course, at that time, the massive like, okay, we keep one more term. And actually, some of this is not new. And I was interested in your point about externalities, great technology, but then the world changes and suddenly that technology is not going to work. The history, the hydrothermal process that we're operating is that the process got to about TRL7 in about 2008. But it was there trying to basically take oil out of lignite coal. And then something called the financial crisis hit, and then it's kind of banned. And it was only really when another crisis came along, something called plastics, that the connection between polyolefin post-consumer packaging and the technology, can we turn that into something of use? It's making circular kind of hit. It's a team that there's now grown into Europe. So the point was made by yourself, Jeremiah, earlier on, was about TRL7. It seems like a long way to go. We've been thinking about it. It's taken us 6 years to get TRL7 to TRL9. And our first commercial scale plant is in commissioning now, or operating by the end of the year, and 2 others. I think one of the barriers that people think about here is that we need to understand everything about your process before you embark. And I take the point about we need to build things, build, measure, learn. If we didn't build anything, we wouldn't have this conversation now. So we have to learn from the pioneers. We have to be pioneers for the next generation. So the challenge, I think, is not enough to move forward. Looking at pyrolysis, there's still an awful lot of research going on. We just had the whole session earlier on, so we haven't learned anything about pyrolysis. Been around for ages. Say that hydrothermal, working with Kevin's group, to fill in some of the gaps, but he hasn't stopped us building a commercial scale plant. So for me, the technical challenge is having the confidence to build something at scale, because we need to get to scale for 2 reasons. One is confidence in supply and the market, a competitive piece within Europe, and also then to de-risk the technology. The more you build, the more you learn, the better it will be, the more efficient, less carbon intensive, and so on. So I was really hard to see the Horizon projects be funded in the way that they are, because that's about making that step change into TRL7 and then going.
Yeah, thank you.
Yeah, so what of it?
Yeah.
From my viewpoint, I'm glad to see that the pyrolysis technology really matures. It's not some magic wand anymore that transform very nasty waste into perfect products. But it's more and more getting realistic, and they are really in these projects that are presented here. You can see that huge amount of experience is ongoing, and as I see from the point of our project, it's always you discover something that you never presumed before, you always encounter some new problems when you tune to it. So it's very hard to predict, and you have to learn by doing it, basically.
Yeah, certainly, and obviously to get us where we are today with our linear economy, we've had the opportunity to learn a lot, so we'll have to do the same here. Maybe coming back to you, Aziton, what are some of the key challenges as Prime that you're now facing to move forward? Or in general, what do you see? We've made a lot of progress. What are some of the key challenges you see ahead?
One of the main challenges are related to the purity of the feedstocks. Actually, whenever we are going for scaling up, that means we are going to even import and process lots of feedstocks from different places. Like in the context of eLECTRO project, we are processing so far feedstocks from 3 countries, and we are waiting for 2 from Far East, from Korea and Indonesia as well. It's about uncertainty. You don't know what you have in the feedstock. So it could be in terms of quantity of this impurity affects the entire process. You might have lots of metals, PVC, PS, PET, which affects not only the quality of the final product, but it does affect as well the entire plant. It might be risky for the reactors. It could damage, literally kill the reactor. We are producing like CL, HCl, and we have some other points related to the safety of workers. So you have multiple issues which are related directly to the impurity. And unfortunately for impurity, we don't have like state process. It's variable. Sometimes you have feedstock with less than 1%, 2% of impurity. Sometimes you might have faced one challenge with one of these feedstocks with 33 plus impurity. So the variability builds another layer of complexity. So we are not only dealing with impurity, but with different types of impurity, unknown impurity, and here comes the, I think, the characterization for both of the from A to Z characterization of feedstock, as well as characterization of the valuizate oil. We need to characterize feedstock to have very detailed information about this feedstock in such a way we save the process. At the same time, we can optimize the process. We cannot say we are going to optimize the process blindly without knowing which kind of feedstocks we are dealing with. So first of all, the core is about the impurity, and this impurity has uncertainty, variability, and to be in like in the dark room, you need to have a light, and I think characterization is the light which should be shed on the feedstock itself as well as for the final product, because we cannot say whether we are improving this process, whether we are optimizing this process or not without characterization. And I think even in the LCD and in the context of eLECTRO, colleagues, they are doing very good work in characterization. So for this part, I think we are facing challenges and are overcoming these challenges. And I don't think we're gonna have single optimum, let's say, solution that suits everything. Like for instance, we need to have the right feedstock for the right process. We cannot say we're gonna gasify bed, for instance, or go for like for instance for pure PS or a high level of grade of PS to be composted, gasified, etc. So we need to have, for instance, the feedstock with high purity to go for mechanical recycling, different feedstock to go for chemical recycling, and in this case, we are not going for competition between mechanical and chemical recycling, other ways. It's completing each other. It's like synergy. It's fitting the right process for the right feedstock.
Yeah.
And I
You clearly highlight when we talk about chemical recycling, we're not talking about one technology, but a range of technologies. And obviously, if we talk about plastics, there is not one type of plastics. We talk about a range of plastics.
Yeah, so I think we should be in collaboration even with other companies like R&D centers, even for this one. The right like process the optimum one for the right like feedstock. At the end, we are not competing actually.
Yeah, thank you. Nico, from your perspective, what are some of the key challenges you see in your work and in your project?
Yeah, so we whole project we deal with the purification of pyrolysis gas. So so the impurities are quite a challenge. There are so many possible impurities that you can encounter with pyrolysis gas, which is a bit simpler than pyrolysis oil. So I guess the cleaning of pyrolysis oil is even much more complicated theme. And yeah, so it requires quite a large knowledge about how the impurities from stock behave within the process of pyrolysis or other processes that are used, and how what form are they transformed to gas or liquid or jar or whatever, and to get this complex knowledge about this behavior is crucial. And of course, it's connected with the input that you put with what you put inside with somewhere outside. So
Yeah,
perhaps in different form.
yeah,
So it's quite challenging.
yeah. Thank you. Maybe coming to you then, Jeff. Often we hear as well when people talk about chemical recycling, oh, they're very highly energy intensive. And can you maybe elaborate a little bit what we're doing or what you're doing from that perspective?
Sure, I'd like to go back to the waste story as well, because I think
Okay.
there's opportunities as well as challenges from a market point of view to understand. Kelly mentioned LCA, I think, along the way, and life cycle assessment is a whole world in itself. I think the concern about LCA is that people try and use it to, I suppose, promote their own particular view of the world rather than use it as an evidence base on which we have a conversation. So carbon intensity, more relative to what? Just certain people trying to draw the two together. Is what we have said in our knowledge paper, and with the first advanced recycler to be getting our LCA into a commercial LCI and life cycle inventory data set. I can't tell you whose it is, it's not been announced yet. But the important part is this visibility, transparency, and that goes to the second panel's comments, conversation. I guess with LCA, it's making sure you're understanding your own process, describing that with an ecosystem that sits around it that makes sense. So you're encompassing everything in your boundary that's relevant to your process and your activity. But then secondly, there's this lovely thing called counterfactual credit. So you would have burned the plastic, but no, you haven't. You brought it into your process. That's fine, but you have to demonstrate you made a change to the other system. You can't just claim 2 tons of CO2 saving per ton. There's got to be a change to that. Ton of other waste didn't they go? 2 tons of plastic didn't get put back in that other ton of material. So we have to make sure that when it's claiming avoidance and savings, that they're real. And it's theoretical that you get to things like scope 4, which is much more about planetary saving from a nation state point of view. So I think LCA, we're trying to get the evidence out there, we're trying to get it validated by external parties so that people will then trust the data more. Energy intensity, if you're going to do chemistry, transformational chemistry, you're going to put some energy in. So the other comparator then is what's the issue? What's the amount of fossil oil? How does that compare? What's the cost of that? And with methane emissions being described now as a bit greater than they were previously, thanks to research done last couple of years, we know that the carbon intensity of fossil prices was going up. So for me, it's like, well, what's the intervention? We have to decarbonise as well as become circular. The two have to go hand in hand. Just the point about waste, just very quickly pick up on the points. I think there's an opportunity here as we mature in this sector, as we start to grow. The waste management sector will understand the needs of companies like us about what we want to process, and what can they do to try and improve their waste stream. So that goes right back to design of plastic packaging, how it's collected, and how it's then sorted. So I hope to see the whole system focused. But the other thing, of course, is we're making products to go back around the circular value chain. And we need to hypothecate certain waste streams for certain applications. EWR has done that. It wants recycled content for future packaging, not looking at tyres into future packaging. It's not hypothecated in the way that the regulation is. So we need to think about how the regulation helps to drive the demand side and also focuses in on the quality of material it wants. And I think we focus on the waste of it too much and looking at where this material is going, so that off-takers can take it and use it with confidence. I think that's another chunk. And I think that becomes, I say, a circular argument, that becomes a circular conversation.
Yeah, thank you. And with the point on waste, I want to go back to Stephen now. Another challenge we sometimes hear is like, okay, with chemical recycling developing, I mean, there might be competition for waste feedstock, while we're still incinerating a lot of waste in Europe. We're still landfilling. I know you've done quite a lot of work on that. How do you see that to make sure there is enough feedstock, maybe not sorted feedstock, but how do you look at that from your perspective?
Well, I think the current recycled content is around 10%, so meaning that of 55 million tons, order of magnitude around 5, 6, 7 million tons is from recycled content, meaning that all the rest is still around. The question is where around, and that is another question. So in principle, we cannot say that there is no feedstock because 90% is around. But okay, you need to find it. There are unfortunately numerical solutions for that, and every country is different and every application is different. So that is scientific perspective. It's a simple perspective, but unfortunately it is true. If you look to where is plastic used, let's say 40% is in packaging, of which almost half is in household packaging, and the other half in non-household packaging, order of magnitudes here. So we have looked a lot to household packaging, especially in countries like Belgium, and there you can achieve maybe a 70% collection rate from source separation, order of magnitudes again. So meaning of this 20%, you can go to 70% or 80 maybe, but yeah, of course, people make mistakes. But okay, this is in Belgium where we already do that good, properly. But okay, in the rest of Europe, we have to, Europe is bigger than Belgium, of course. So we a lot bigger. So we need to, and also, first of all, in these other countries, mimic the best practices. In all other countries, we need to collect this household packaging. But of course, also in Belgium and in all other countries, we have to look beyond that. We have to look what happens to the non-household packaging around. A lot of material is there. And then you have to look, automotive is a different story. Automotive second-hand cars go somewhere, we don't know where. So plastics are in there. Then if you look to laptops, plastics are not the most valuable element there. So we lose the plastics in the metal smelters probably, where they are used as fuel, which is okay, not optimal, but they are less valuable for the metal recycler. So there maybe if we want to get the feedstock, we need another tool to convince that electronic sector that plastic are valuable for our society. And so if textile is again a different story where a lot of polymers are used, and which luckily now more and more people start taking a look even at collecting textiles beyond sending it to developing countries, and maybe taking a look to, can we recycle polypropylene carpets, or can we, and what happens to the polyester there and elastomer there? So every story is a bit different, but the feedstock is around. But first of all countries in Europe have to mimic the best practices around, like our household collection system is decent. But then also in countries with some developed systems, we have to look beyond this 20% household packaging and look, okay, where is the rest going? And this is, of course, the more complicated cherries to pick, but this is what we have to do step per step and sector per sector, application per application. Stocks in buildings is different, the in-use plastics in buildings and pipes, that's another question even. So unfortunately, I cannot bring a simple solution here for all this waste, but there is a vision, but we have to get every sector convinced that it's worth collecting and getting the leverages in every of those applications, which is a bunch of work and debates that we have to go on to proceed. But first, the easier cherries picking, but in parallel, we have to pick the complicated cherries. But there is sufficient feedstock.
Yeah. Fully agree. Then maybe coming back to you, Kevin, on, well, electrification, obviously in the chemical industry, we talk a lot about electrification. How important do you think electrification for chemical recycling will be?
I think on short notice, and I think it's not crucial. I think the key element that we need for chemical recycling is really to prove that it actually works in a reliable way. I think with any chemical process, large-scale chemical process, you want to prove that it works 8,000 hours per year, continuous. You don't have to stop. The energy providing, yeah, that it's preferably as green as possible. I think that's the second order effect. Today, we also have to see that if you look at different grids, and we take the Dutch grid, we actually would end up probably with a worse situation than combustion things. Yeah. And that's also the honesty we have to make, is that electrification is good if you have enough renewable electrons, or even electrons from nuclear or something with low CO2 emissions. And today, there's really competition for electrons. And if you look at on short notice where the easy gains are, it's basically in the cars. Then electrification of the chemical industry will be that for me done in the second wave. So today we have to develop those technologies, and it's possible. Probably in a decade we will be there. But yeah, that's in a decade. I think for renewable electrons, there's a priority, and the priority is basically transport. Short notice, but okay, we have to clear that, and then it's a big issue. Really, in electro, we have seen that because of the price of the electrons is also so expensive, and you want to run 8,000 hours, that you even, it's impossible to make a profit even, just because of the price of electricity. Today, so not and this is with not so very high prices. So in the end, the companies have to make a profit as well. We have to really realize that. Then you see Lego, they reduce their margins. But they basically said, we will go for a more expensive feedstock. We will give it on our margins, but we believe that the material of Lego is the best that we have. We have to make it in the end, but from a different feedstock. It will cost us a bit, but that's what we have to do for more sustainability. These are choices that you have to make also to society. And I think that social acceptance is crucial there, and then you need proper information.
Yeah.
And relying on people that you can trust. And that's also now difficult with all these crazy politicians, I would say.
You touched upon social acceptance. I think we are getting into the second panel discussion, and I think we have to conclude this one. I really want to thank all the panelists for the great discussion. I think it's great to see the progress we're making, the technological developments. There is a lot of work going on. There is a lot of progress being made. I mean, changing from a linear to a circular economy comes with its challenges, but it's very encouraging to see all the work going on. Yes, there are still challenges out there, but I think through collaboration with everybody, I think we're definitely making a lot of progress. Looking forward to the next discussions.